This is section 4.8. We're going to be doing the quadratic formula and talking a little bit about that. So I'm going to try, there is quite a bit of material here, not because it's a hard material, but because there's just a couple of different examples that I want to give. But I am going to try and go through this fairly quickly because I know most of you have seen the quadratic formula before, and I don't want to waste a whole bunch of your time. So let's just get right into it. So the vocabulary for this section is the quadratic formula is the formula that can be used to find the solutions of the quadratic equation ax squared plus bx plus c when a, b, and c are real numbers and a is not equal to 0. And the second thing, which you may not be as familiar with, the discriminant. The discriminant is the expression underneath the radical sign in the quadratic formula. So what we want to do is we want to talk about just how to use the formula. So what we did in the last section is we did it by completing the square. And if we were to actually complete the square using this general form of the quadratic equation, then we would get the quadratic formula, which we can use to solve any quadratic equation. So what I want to do is let's just identify what the quadratic formula is. Some of you may remember it, some of you don't. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So what we really need to remember is how to identify our a, b, and c. So here we have a equals 1. Here we have b equals negative 6. The negative comes with it. And c equals 4. Down here, we don't want to identify an a, b, and c until we get everything equal to 0. So we need to bring the 2x and the minus 3 over. So we are left with 5x squared minus 9x plus 7 equals 0. And then we can identify a is 5, b is negative 9, and c is positive 7. So let's go into a quick example here, and then I'm going to have you try one on your own. So this is a step-by-step process. So the first thing is before we solve anything, is we need to get rid of everything on one side and make it 0. So we have to minus 6 to both sides, so we end up with minus 6 here at the end. So then what we want to do is, let's recall the quadratic formula, negative b plus or minus b squared minus 4ac, square root of all that, over 2a. So then when we identify our a, b, and c, we get 1, we get 7, and we get negative 6. So when plugging this in, we have a is 1, b is 7, and c is negative 6. So we end up with opposite of b or negative b, so that's negative 7 plus or minus 7 squared minus 4 times 1 times negative 6 all over 2 times 1. And evaluating all of this out, what I do is I evaluate what's underneath the square root first. So that would be 49, and that will be a negative 24. So you have 49 plus 24. So what I end up with is negative 7 plus or minus the square root of 49 plus 24 all over 2. And then when we simplify what's in there, we get x equals either negative 7 plus the square root of, and that ends up being 73 when you add those together. Negative 7 plus square root of 73 over 2, which is approximately 0.772. Or we get negative 7 minus the square root of 73 over 2, which is approximately negative 7.772. Okay, so that kind of gives you an idea of how we want our solutions. Now, typically, you want to have a good idea of how to give the solutions like this. It's not always plug it into a calculator and give me a decimal. You need to understand how to simplify it like this, because sometimes on a multiple choice test, that's how it's going to be listed, and you need to know how to get there, especially with reducing radicals if possible. So here's what I want you to do. Try this one on your own. You can give me the answer. You can give me the answer as a decimal as far as the Ed puzzle is concerned. But you still want to be able to write it out and see what your final answer would be in terms of this. Okay, you just don't have to write it in Ed puzzle. So try that, see how that goes. So you should have gotten x is approximately 6.14 or x is approximately negative 1.14. And you can see the steps that I have here and pause the video as needed to look through them. I'm not going to go through it step by step. You try and figure out where you may have gone wrong, but I do have every step there. That shouldn't be an issue. So moving on, we have another type of problem. So in the previous problem, we got two solutions. Sometimes when we solve using the quadratic formula or any quadratic equation, we're only going to get one solution. So let's see how that would work. And hopefully you'll start to understand when you're going to get one solution, when you're going to get two solutions, and then in some cases you'll get no solutions, which causes us to get imaginary. So in this case right here, we have our formula. Our a is equal to 2, our b is equal to negative 8, and our c is equal to positive 8. So negative 8 turns into a positive 8 plus or minus negative 8 squared minus 4 times 2 times 8 over 2 times 2. That leaves us with 8 plus the square root of 0 over 4. So because we have plus or minus. So because we have 8 plus or minus the square root of 0, the square root of 0 is always 0. So adding or subtracting 0 is not going to change anything about it. We're always going to end up with 8 divided by 4, which is just 2. So we only have one solution here being 2. Okay, so that's the case where you will only get one solution. Okay, why don't you try this one on your own? So for this one, again, you should have gotten 0 underneath the square root, which means we will only have one solution. You should have ended up with 40 over 32, which if you reduce that, that is 5/4 or 1.25. Okay, let's move on to the last place, which is what happens when you have imaginary solutions or no real solutions. So in this case, same type of formula. We're going to end up with, we have to minus 5 to both sides. We identify our a, b, and c. A is negative 1, b is 2, c is negative 5, and we start plugging in. We have negative 2 plus or minus 2 squared minus 4 times negative 1 times negative 5 over 2 times negative 1. That leaves us with negative 2 plus or minus the square root of negative 16 over 2 times negative 1. So again, the problem that we have here is that we have a negative underneath our square root. So because we have a negative underneath our square root, we know we're not getting real solutions, but we can get imaginary solutions. So we should end up with negative 2 plus or minus, and the square root of 16 is 4, and then the negative becomes an I, so negative 2 plus or minus 4i divided by 2. And then when we simplify this, negative 2 divided by 2 is negative 1, plus or minus 4 divided by 2 is 2i. So our two solutions are negative 1 plus 2i and negative 1 minus 2i. So that's an example of where you get imaginary solutions. Why don't you try this one and see how you do? So here you should have gotten 3 plus I or 3 minus I. You should have ended up with a negative 4 underneath your square root, which then gives you plus or minus 2i, and then simplifying 6 divided by 2 is 3, 2 divided by 2 is 1, 3 plus I or 3 minus I. Okay, moving on, let's talk a little bit more specifically about what is underneath that square root, and we call that a discriminant. And what does it mean? The discriminant tells us a lot about our problem. For example, if our b squared minus 4ac, that's what's underneath the square root. So basically saying whatever's underneath the square root, that is called the discriminant. If that is positive, greater than 0, that means we will get two real solutions. Which means the graph is going to have two x-intercepts. If what's underneath the square root discriminant is equal to 0, then we're going to get one real solution. And the graph will have one x-intercept. When b squared minus 4ac is less than 0 or negative, the equation is going to have no real solutions. Okay, which also means that you're going to get two imaginary solutions. And we will get 0 x-intercepts. Okay, so moving down, or let's just move straight across to these graphs right now. So what you want to do is you want to look at these graphs and make a connection between the two. Remember, everything that we're looking for, everything that we're finding with the quadratic formula is solutions. And we're looking for x-intercepts. So when something has two real solutions, you expect it to cross the x-intercept at two different points. So down here, this is where you would have two solutions, as in this last graph, because we have an x-intercept here and an x-intercept here. So there's two solutions there. And then we go up here. Here's the instance of where we will only get one. The graph comes down, touches the 1 point, and then goes back up. So there's only one real solution there. And up here, it doesn't cross at all. So we have no real solutions. Okay, so our imaginary solutions come when we see a graph like this. So let's find the discriminant of each of these and talk about what we know about them. This will be really easy. So the discriminant here will be, in the first one, will be 36 minus 4ac, so 36 minus 20 is equal to 16. Because it's positive, we expect to get two real solutions. In the second one, we get 36 minus 36, which equals 0, so we expect to get one real solution. And in the last one, we get 36 minus 52 is negative 16. And because it's negative, we will get no real solutions or two imaginary solutions. And then this chart down here should help you a little bit, to kind of put together this chart that we did above. But this is just for a reference. It's something that we really need to get a grasp on, that when we use the quadratic formula, if we get a positive value underneath the square root, we know that we're going to get two solutions because we have a plus or minus sign. So plus a value minus a value gives us two different solutions. If we have 0 underneath there, we know it's just going to be this solution divided by whatever's on the bottom. And then if we have a negative underneath there, we can't really take the square root of a negative number and get an actual solution, so we know that we're going to get two imaginary. So that's all I have from this section. I hope that this is really straightforward. I know it can be a little bit tedious to plug the numbers in, but at least it should be a straightforward way to solve quadratics.